Hi everyone, my name is Ashna Sisodia and you are watching this session on Unacademy's YouTube channel UPSC Articulate. In today's session, in Crucial Topics for Geography, we are going to discuss the origin of Earth and the evolution of the solar system. The solar system is a fascinating place with 8 planets that are orbiting around a central star known as the Sun. The origin of the solar system has long been a subject of intense scientific study and speculation. Man has always been curious about how the Earth came into existence. And over the years, scientists and philosophers have debated the origin of the Earth and the solar system and have put forward several theories and hypotheses. Among the early theories, the most prominent were gaseous hypothesis of Immanuel Kant, nebular hypothesis, then we have binary star hypothesis, etc. We'll be talking about these hypotheses today. But before that, the most widely accepted theory you must know is the nebular hypothesis, which was first produced by Immanuel Kant and later on Laplace in the late 18th century. So let us start with gaseous hypothesis. Please remember about the origin of Earth that the origin of the Earth occurred about 4.54 billion years ago. The lithosphere, the atmosphere, hydrosphere of the Earth, they were formed as a result of Earth's evolution. Additionally, it explains how life emerged during Earth's evolution. In the upcoming sessions, we will be focusing on how life first emerged on Earth, what is the geological history of Earth, all these things. So let us start with our first hypothesis, which is the gaseous hypothesis. Immanuel Kant, he proposed this theory. He is a German philosopher and he proposed the gaseous theory in 1755. Actually, he assumed that there was a slowly rotating cloud of gas that composed of cold and solid and motionless particles. These particles, they started crashing onto each other due to gravity, as a result of which the heat generated induced angular momentum and the cloud began to rotate. As the cloud, you can see in this picture itself how it is rotating. As it begins to rotate, the heat increased and the heat generated induced angular momentum and it increased the size of the cloud as well as the speed of rotation. Gradually, it started spinning so fast that irregular rings began separating from the middle part. And eventually, the residual central part formed the Sun, and the planets and satellites gradually developed from the rings. So, this is how it looks today. Gaseous theory is something that was proposed by Immanuel Kant and later on this was taken over by Laplace. Remember that. Now let us go ahead and cover our next theory, next hypothesis, that is nebular hypothesis, which was proposed in 1976. This was given by Laplace. In 1976, he is going to revise Kant's theory, which assumed that a huge and hot gaseous nebula rotating on its axis. Due to the circular motion, this nebula was losing heat by the process of radiation. And because it was losing its heat due to this cooling, the nebula gradually decreased in size and volume. And when that happened, when this decreased in size and volume, gradually the outer layer cooled and condensed so much that it broke away from the center part of the nebula. Now, the materials of the ring eventually agglomerated to form planets. So, please remember regarding this that gaseous hypothesis can be sometimes known as the nebular hypothesis. This suggests that our solar system was formed from a giant cloud of gas and dust, which we term as nebula. The next we have planetesimal hypothesis. Now this is proposed by T.C. Chamberlain, and this is proposed in 1905. T.C. Chamberlain was a geologist and he put forward this theory in 1905, and according to this theory there were two stars. There was a protostar. So the sun that we have today, let's refer to as protostar. And according to this theory, there was another star, and he called this star as companion star. So according to Chamberlain, when the companion star came close to the protostar, at that time numerous small particles got detached from the outer surface of the protostar. And because these particles got detached, later on these particles were termed as planetesimal. So few planetesimals were quite large, those, and as well as some small planetesimals were also there, because these large planetesimals are going to attract small planetesimals out of the surface of the protostar. So as planetesimals were added up, they eventually grew in size and form planets. So this is the planetesimals hypothesis. Next we have tidal hypothesis. Now it is proposed by James Jeans, who was a British scientist, and he propounded this theory in 1919. And this theory was later modified by Harold Jeffrey. And that is why sometimes it is said that this hypothesis is given by Jeans and Jeffrey. Harold Jeffrey revised it, or we can say modified it, in 1929, a decade later. According to this theory, there were two stars. There was the primitive sun, the sun that we have today, and this is the early stage of the sun, by the way, and there was a large intruding star. So the intruding star, it came very close to the primitive star, as a result of which hot gases rose due to strong gravitational forces. So here the gravitational forces are coming into play. Remember that. So as per this theory, because of the tidal pullout, because of the gravitational forces, gaseous tides arose, and when the intruding star was closest, at that time cigar-shaped hot gaseous particles were separated from the primitive sun. And this cigar-shaped, this is called as the filament. Now, bigger gaseous planets formed at the center of the filament. So this converted into this. Okay. So bigger gaseous planets formed at the center and smaller planets formed on both sides of the filament. So this is the tidal hypothesis. That is the gaseous tides that came out, that arose because of the strong gravitational forces, because of the intruding star, because it came very close to the primitive sun or primitive star. Then we have binary star hypothesis. Now this is proposed by H.N. Russell, and this is proposed in 1937. According to this theory, there were two stars, and these two stars, one star was the primitive sun and the other one was, let's name it as the companion star. Now this theory says that the companion star, it revolved around the sun and it ejected mass during the influence of another star which was approaching the companion star. So, what really happened in binary star hypothesis, that suppose this primitive star is our sun and there was another sun, or you can say another star nearby. So, what happened to this companion star? Nothing happened to the primitive sun. Actually, there was an intruding star, which you can say, that was passing nearby, and under the influence of this star, which was approaching the companion star with a very high speed, this ejected a mass, and this mass eventually formed the planets. So, this is the binary star system, binary star hypothesis. Then we have our last hypothesis, that is supernova hypothesis. Now, this is proposed by Fred Hoyle, who was a mathematician of Cambridge University. He presented this theory as supernova hypothesis, which was presented in 1946. This hypothesis was based on the principles of nuclear physics. According to this hypothesis, there was a primitive sun and there was a companion star. The companion star exploded because of the nuclear processes. So, according to this, when it exploded, it produced a cloud of gases. As you can see in the image, now there's a gaseous cloud. Now, the sun's gravitational pull kept these gases and remnants of the star together, and these particles eventually formed the planets after gradually cooling over billions of years. So, this is how our solar system has been formed as per this hypothesis. So, today we have discussed all the hypotheses related to the origin of the solar system, the evolution of the solar system. In the upcoming session, we will be discussing geological history of the Earth. This is it for this session, guys. Thank you very much. Bye-bye. Take care.